Okay. I am recording. So let's jump straight to the topic of today. So today we have PLD sorting insertion, and let me just read a bit from the start. Sorting is the act of rearranging element in sequence in order, either in numerical or lexicographical order, and either ascending or descending. A number of basic algorithms run in what is called is this 2 power of 2, I think, and should not be used in interview. In algorithm interview, you're unlikely to need implement any of this sorting. Okay. Okay, please mute your mic, Felix and Jarabi. In algorithm interview, you are unlikely to need to implement any of the sorting algorithm from scratch. Instead, you will need to sort the input using your language default sorting function so that you can use binary search on them. On a sorted array of elements, by leveraging on its sorted property, searching can be done on them in faster than on time by using binary search. Binary search compare the target's value with the middle element of the array, which inform the algorithm whether the target's value lies in the left half or the right half, and this comparison proceeds on the remaining half until the target is found or remaining half is empty. So feel free anyone to talk, to share, to ask. So we see today topic gonna be about binary search, and the essential question they give us is this 2 lit code that we're gonna solve together, and if we solve them both we can solve other ones that's a bit more hard than this one. So let's see. Now we watch just a quick video so everyone can catch up about binary search, and this one is really quick. Okay, let's go.
Binary search in
Let me share screen. I don't think you can hear the volume. It's 1 second.
the dictionary. You wouldn't flip every page until you get to M. Instead, you open it in the middle. If you overshoot to the Q's, then you go to the middle of that chunk. This time you undershoot to the J's, so you do the same thing again, but in the other direction, until finally you find the page you're looking for. Easy enough. Now it's time for your technical interview. You might be given a question like, given a sorted array, write a function that returns the index for the given element. The easy way to solve that problem is with a simple for loop. Just loop over every element in the array until you find the one you're looking for. That works, but you fail the interview because you need to go faster. A regular loop results in linear time complexity, but you can do better than that. Here's how we might map out a binary search on a whiteboard. First, we need to figure out the middle index. Instead of starting at index 0, we start in the middle. If it's equal to the target, then we return that index. But if that element is greater than the target, then we know the target must be somewhere on the left, so we find the middle of that slice of the array. But if it's less than the target, then we know the target is somewhere on the right, so we repeat the process for that slice of the array. The result is a much faster algorithm with logarithmic time complexity because it's able to divide and conquer. Now, to implement the code, we could use an iterative approach with a while loop or a recursive function. Either way is acceptable, but let's define a recursive function in JavaScript. The function takes the target value as an argument, as well as a starting and ending index. First, we have a base condition to stop looping when it reaches the end of the array, at which point we know the target is not in the array. From there, we compute the middle index, then we check to see if that middle index is equal to the target, at which point we can return because we found the element we're looking for. Otherwise, we need to continue searching, and that's where recursion comes into play. If the middle value is greater than the target, then we'll call the same function, but this time we'll put the ending index at the middle. The other possibility is that the middle value is less than the target, in which case we can also recurse, but this time we'll put the starting index in the middle. And now we have an algorithm.
Wait, Sumay, you can share? Can you confirm someone can hear?
I can hear clearly.
Okay, maybe Sumay, you need to hover over stream, you're gonna see in the bottom right, like icon for the volume.
For them, that can find an element in a sorted array much faster than a regular loop. If you want to see more videos about algorithms on this channel, hit the like button and let me know in the comments. Thanks for watching, and I will see you in the next one.
Okay, was just a warm up. This was just warm up. The real video maybe is this one.
Today, I'm going to teach you binary.
So that's one, like, just give us idea about binary search before we start Let's Code, just in case someone never heard of them or something. He will kind of follow with us, like when we start Let's Code.
Binary search. Binary search is a fundamental search algorithm that finds a target value in a sorted array. With each iteration of the algorithm, half of the remaining values in the array are eliminated. Let's use this array.
Hello, Monsif. Can
Hey.
you hear me?
Hey, I can hear you. Yeah, welcome.
Yes. Yeah, sorry to disturb. I don't know. I can't see your screen. It's just loading.
Oh, it's maybe from your internet.
Value of 12. We'll start by finding the middle value of the array, which we'll calculate using the leftmost and rightmost indices, shown here.
So the idea is we have array, right? And binary search is when we're gonna do binary search, we have the array to be sorted. So the array is sorted, and basically we're gonna always have like 3 pointer, one to the head and one on the tail, or like one on the first element and one in the far right. And we have the middle. We always look for the middle. Then either we're gonna search on the left side or we're gonna search on the right side.
We'll take the average of the indices, which is 6. I chose to round down. You can do either, just stay consistent. The 6th index is the value 15, which we'll mark with mid. 15 is greater than our target, so we'll eliminate it and all the values greater than it by moving right to the left of mid. Repeating the process, we'll find the new average of the left and right indices. This is index 2 with a value of 5, which again...
Hello? Something... I can't hear anything now.
Yes,
Okay,
Monsif, video
let me see again. Check now.
is 6.
Clear?
I chose to round down. You can do either, just stay consistent.
Yes.
Can you hear?
The 6th index is the value 15, which we'll mark with mid. 15 is greater than our target, so we'll eliminate it and all the values greater than it by moving right to the left of mid. Repeating the process, we'll find the new average of the left and right indices. This is index 2 with a value of 5, which again we mark with mid. 5 is less than 12, so we eliminate it and all the values lessen it by moving left to the right of mid. Again, we find the middle, which is index 4 with a value of 9. This is less than
Okay, I
12,
lost
so we
focus.
move our
I will
left pointer
repeat,
to the
please.
right of mid in a sorted array. With each iteration of the algorithm, half of the remaining values in the array are eliminated. Let's use this array, for example, with the target value of 12. We'll start by finding the middle value of the array, which we'll calculate using the leftmost and rightmost indices, shown here. We'll take the average of the indices, which is 6.
Oh,
so the
finally it
target
has
is-
shown.
Okay, welcome. We just started video. So the targets we're looking for is 12. So we choose
I chose to round down.
0 and 13 because the index 0 and 13, and we choose the middle is 6, index 6.
You can do either, just stay consistent. The 6th index is the value 15, which we'll mark with mid. 15 is greater than our target, so we'll eliminate it and all the values greater than it by moving right to the left of mid.
Okay, why I did choose why element right? Why not element left?
What do you mean?
Because the target is lower than the midpoint. So everything after the mid, it can be eliminated. It's higher than the target already.
Okay, I see. So like he did 12. I compare 12 with the middle. Then he decide, okay, because it's
It doesn't
lower.
matter what's below the midpoint now. He just changes the right from 15 to right. So he eliminated all the element after the middle, between the middle and the 15, which was the previous right. He eliminated all of that. Then the right is the element right before the mid minus one, which is the new right.
Okay.
Then you search for the middle again between this new right, the index of the new right and the index of the left. You can search for the midpoint. Then repeat the process again. It's a while loop.
Okay. I see. So you get the target, and then you get the middle, and then you compare them, right? And then you decide from that which part you're gonna focus on.
Yes, you can. You decide if you will go left or you go right. You increase the left or you decrease the right.
Okay, let's keep going. Thank you.
Repeating the process, we'll find the new average of the left and right indices. This is index 2 with a value of 5, which again we mark with mid.
Okay, now we split this part right here.
5 is less than 12, so we eliminate it and all the values lessen it by moving left to the right of mid. Again, we find the middle, which is index 4 with a value of 9. This is less than 12, so we move our left pointer to the right of mid. Now our left and right pointers both point to 12. One more time, we take the average and get a value of 5. Our mid equals our target 12. We return 5, which is the index of 12. Here's the code for binary search.
Okay, maybe we don't see the code until we try to solve the let's code. Let's see what you're gonna do here.
The root node will be the middle element of the array, 15. The left child of the root will be the middle element of the lower half, and the right child of the root is the middle of the upper half. We follow a similar pattern for the remaining nodes. I won't prove it here, there's further reading I'll link in the description, but the height of this tree is the floor of log base 2 of n plus 1. Each progression through the while loop, we descend one level down the tree, and worst case, we may need to go to the deepest level, as we did in our example. As a result, we can say the time complexity of binary search is big O of log n. Thank you for watching.
Thank you, sir. Okay, any question? Is everyone got idea about binary search? Please don't be afraid. Open mic, ask or share if you have idea or if you wanna explain something. Okay, now we're gonna jump to let's code. So the let's code, the first one they give us is binary search, and this is like essential one that we need to solve. These two. So the first one is binary search. Chaza, you want to read?
Okay, we can read the problem itself.
Yeah. Or
Okay.
do you want to explain it later? I can read.
Maybe highlight some things. First of all, there was a discussion between me and Mosef. I asked him in the technical handbook, which is our resource. I said to him, although the title of this PLD of today or title of this plan, this lesson is about searching and sorting, but the problems here in today's lesson is about searching, not sorting. So we found out that there is like a note from the author of this book. It said that in algorithm interviews, you are unlikely to need to implement any sorting algorithms from scratch, meaning that it is low probability that your interviewers say, hey, please implement something like merge sort from scratch or something. I think maybe he asks about your explanation or understanding of it, but as per the author's point of view, he said that instead you would need to sort the input using your language default sorting function. Like I think we have sort in JavaScript, and I think in Python, and I think all high-level programming languages has its own built-in sorting functions. So I think this is the reason why maybe all the problems today all about searching methods and search algorithms. The most important among them for sure is binary search, even in direct way or modified as we will see today. But the reason is if you think about, let me whiteboard something.
You can share screen if you want.
Okay, it would be better.
Okay, let me stop sharing. Can't see.
Okay. If some, for example, we have an array like how this could be done like this. Very beautiful handwriting. Okay.
It's better than mine, at least.
You think so? And it, I can put here what? 2. Okay. Here is 5. Wait, here. Oh, sorry. Here. 5. Every time I will click this. Okay. 10. Here is 12. Then 15. Let's say, okay, here is 15, 17, okay, 20. Okay, let's say we have this array. To search about any element in this array, you have 2 choices, even the first one and the very bad one that we have not to say to our interviewer is that I will move from the first to last in brute force, like checking each element, is it the target or not? Because this is, as we may know, this is what O of, I think we are saying O of n, okay? But we have to go for further algorithms that can take the time complexity into something less, which in that case will be O of log n, and we will see array. So we may ask our interviewer, is the array sorted or not? If it is not, we will sort it first to be able to go for a binary algorithm. This is the first thing I wanted to highlight. Okay, another thing is about space complexity. In the binary search, the iterative, it may be like our algorithm, which we will see it with the iterative approach. You are using a fixed amount of space which is relevant to the input, but there is another a way which is recursive approach. It isn't as good as the iterative approach in terms of space complexity, because as we may know that the recursive function calls take from the heap stack. So it may be not O of 1 if we solve it in recursion, and this lucky us that we will not need to use recursion. So let's jump in about binary search itself, or how we are going to do this. As we have seen here, the first element is the least. It is very correctly ordered in ascending way. Okay, so how to implement, Monsif, any idea how to start the idea, depending on that? For example, we are searching for Let's say 12, for example.
Okay, that will be easy, I think.
Target.
Let's maybe choose 50 because it's gonna be in the middle, right?
Okay.
So if we split, we're gonna.
Okay, I'm searching for 17. Huh?
Okay. Okay, someone help me, please.
Yeah.
I forgot all.
And
What's
you can just pick. You can pick. What's the name? 10. 10 is okay.
10. Okay, they are helping you, ya Monsef. 10.
Okay, 10.
Let's make 10. Okay. 10. Okay. So how can we start it?
We need 3-pointer. Pointer at the left will be index 0. Pointer at the right will be index in 20, but I don't know how much. And we have the middle.
Okay, let's call it, for example, at 2, we call it like
L and L. L and R, or left and right. It's the easiest.
And I call it, okay, here, right. Okay, then.
And then we need another pointer, the middle pointer.
Okay, let
Mid.
roughly mid to something like let left, for example, like it will be 0, right? And right will be like the length of the array. I call it
-1.
Okay, length of this array -1. Okay, and
minus need to close the bracket, then -1.
I'm not coding. This is
yeah.
rough
Okay,
coding.
that's
We'll go
just
for lead code. Just as
I know.
rough.
I know.
Okay.
The midpoint will be left minus right divided by 2.
Can you zoom a bit?
Right minus
The
left.
whiteboard. Okay, perfect.
Right minus left, not left minus.
I think it's right minus left. Yeah, that's correct.
Right minus left. Yes, left is 0. How we can subtract from 0?
Yeah. Right minus left.
Right minus left and
divide by 2.
Okay. Okay, we have now 3 pointers.
I think plus, not minus. Left plus right.
Yeah.
Right.
Yeah, they're
exactly plus. Yes. Yeah.
plus.
Sorry.
So like.
And right n minus 1. Right بتساوي n minus 1.
Okay, mid equal. You can tell me.
Okay.
A second, please. A second. Excuse me.
Yeah. Mahmoud, you have. Maybe you need to use push star. Wait. What is this noise? Lone wolf, I think. Please, guys, if you're not gonna talk, like, keep the mic muted until you wanna talk.
Sorry. Can we confirm that formula? I don't think it's. I'm having doubt that it's plus. I don't know if I'm wrong. Please correct me.
So
I think it's.
It's minus. It's right minus left, then divide by.
It's minus.
I think maybe there's many way to do it, and.
What do you think?
Okay, let's do something. Let's say we are. Our first is in like. So can you point to 12 with like different color?
Okay.
Different color to 12.
Can we like map it a little bit, like give it an actual value, so we know in what iteration we will gonna use? Like left will be 0 in this case, right will be.
So in this case we do 12. Let's say we are first is 12
right
and the end is 20. Like the far left.
No, the index. The index. Do know which index are we talking about? So we know which
like
one.
12, like 0, 1, 2, 3.
12 is
index 3.
The right will be index 6. In this case, I guess.
So like
I think that's a great idea. If we could possibly just label the indexes of the array as well, just for clarity.
Each iteration of the array, we know what index we're talking about. So left is 2 in the first iteration, right now will be 6, and the middle will be 3.
So Shaza, do like for each part of array 0, 1, 2, 3, 4, 5.
Okay, indexing. I should add the index.
I believe so. Is that
yes?
Yes, that's
Yes,
what.
please.
1. Here it would be 2. We are drawing
4,
4, 5, and here is 6. Okay, let's go. So
okay, so fat boy. Okay, so someone in the chat did write to two-way to find the middle. That's why we are like confusing, because there's two-way. So there is L plus R divide on 2, or there is the other one.
okay, is like left. You mean sorry. The first way is right. Okay, minus left divided by 2. This is the first way.
No, plus.
Way,
plus. So we
right
add them
2?
both. Yeah.
Okay. Okay. Like sorry, like this.
Yeah.
It will be 0.
No, I don't think this is the right way.
I doubt it.
Yeah, even me, I don't think it's the right way, because when I did it in the tax, I never used plus. I don't know, but it's fine.
Yeah,
it's
fine. I did use, when I solved this task, I did use this way: right plus left, divide on 2.
So Monsef wins.
No, not me win. There's 2 ways, you know.
But I done this way, right plus left. Are you sure you use?
Yeah. Let's do the example. Let's do example. Let's say our right is 12 and x 3, right? Let's do this equation. Let's say our left is 20. Okay, can you write 6 minus plus 3?
Okay, 6 plus what?
3.
Okay.
Yeah.
Sorry,
Like
6, 7, 8, 9 divided by 2.
I didn't understand. You mean like this?
So 6 plus 3, what is that? 7, 8, 9. 9, right? And 9 divided by 2, and because we have integer here, it's gonna be what? 4. It's gonna be 5, right? Isn't that 17? So that is the middle that we're looking for. No, it's gonna be 5, because 9 divided on 2 is 4. 4, that's 5. So it's gonna add the other. So it's gonna be 5, right? So it is the index 5. Both of the equation are gonna give you 5.
You mean index 5?
Yeah, isn't that the middle of 2?
Will be 4, because 9 divided by 2 is 4.5, and this will plus 4, not 5. It goes to the lower, not the upper, I think.
exactly. It's 4.
Really?
It's not 5. It's 4. It's 4.
Okay, so the index here is 15.
I want to add something.
Wait. Can we do the other equation, because I think the bots they're gonna ping the same.
Let's just work with a life scenario, like a problem. I think she was trying to solve it. Let's just work with the problem the way we've been doing it. If we start guessing like this, we might be getting funny midpoints. So let's just go with what she's doing, the presenter, and let's just continue from there. That's my suggestion, anyways.
Yeah, but I think if we understand, like, if this both equation give us the same value, I think we're gonna learn something from it.
The problem is sometimes there is another implementation of binary search, each of which you have a different implementation of the middle. You are differently calculate the middle, so it's crucial to know how or what is the correct way to calculate the middle.
Yeah, I believe so. Now we know the first one, it give us index 4, right?
Okay.
So let's calculate with the other equation and see what number it's gonna give us.
I should write 4 instead of 5.
Okay, so they correct me. They say that when they do the floor, it give you the list, like it remove that's 5, so it's gonna be 4.
Okay.
I actually was thinking it's gonna be 5.
But Monsef, there is 2 mistakes in this.
I don't agree with this, by the way. Okay.
You will you should put right plus left in practice, because when the program is solve this, will solve left.
Yeah, I get you. So right and left, it should be between the brackets, right?
Yes, yes.
Yeah, not bracket, the parentheses, because the priority gonna go to dividing.
Like this.
And right length array -1 is mistake, because you want to array and close brackets and -1. يعني خرجي -1 بره البراكتس.
Sorry, do you know why I disagree with this? Because you know the pointers are moving. It's not, you can't just keep the last pointer at 6 and you've already moved to the left to where you are at now. That's what did you calculate there? 6 plus 3 or so. So you know that they are moving. Both of them are moving at the same time. That's the implementation. That's why I said that if you do it like this, you might be getting a funny value. That's the truth. So actually, I disagree with this method anyways. But you can continue, it's fine.
But it did work. That's what I don't get.
Hello, guys.
Yes, hello.
How can the left, no, my question is this, how can the left already get to 4 and the right is still at where it is, it's just there. They need to move. You understand? So that's why I'm thinking your implementation here is, the way you are doing it is not, I don't think, you're just doing it based on mathematics. And that's how I see it.
Okay, to not waste more time on this point, let's continue on one way. Let's use the way that most people say, not this one, the other one, and let's continue with it. And then we can come back to this point of the middle after.
Okay, we will suppose that we calculate the middle, okay, and a second, please.
Okay. Can someone in the chat write the other condition? So like the one I was talking about is this one, right? So if we suppose the index right is 3 and the max left is 6, so it's gonna be like this, right? Can someone else, Pascal, can you write the other, or Manetella, or someone else?
I want to.
Sorry, what are you asking about? I'm confused. What are you asking about?
Sorry. Like the mid equation. Like what is the equation that you said it's supposed to be, or the right way?
Okay, it is mid equals to right minus left divided by 2.
Oh, wait, right minus, okay, right? Can you write minus, can you write this in chat, please? Right minus.
No, she's getting it divided by 2. Yeah, she got it.
Okay.
Like this.
You see, this equation is correct. However, there's only one thing you need to do after doing that, is that you need to add whatever you've calculated, whatever value you've calculated from that right minus left divided by 2. You have to add it to the left to find the actual midpoint. It's almost as if it's a relative distance at that point. But as the left and the right changes, you're going to have to constantly adjust the left. You have to add the value to the left to get the actual midpoint, the distance from the midpoint, the left to the midpoint. So the minus works, but the addition, if you do the addition way, you don't then have to, add it to the left value in order to get the actual mid. So with the addition one, it's already just inbuilt. It'll give you the index of the actual mid without you having to adjust it later. It's just two different ways of doing the same thing, essentially. But the first one is the one that has the fewest calculations with the addition.
Okay, I'm still confused a bit.
All right, no problem. I get it now.
So like if I did, so I guess we need to, like, is this gonna work, like if we put it like this? I don't think it's gonna work, right?
It'll only work for the first calculation when it's 0 and then 6, right? Because you're looking at the entirety of the array.
Yes, yeah.
And then when you adjust it later, because after this, right, you have to check if the mid is actually equal to the value, sorry, that you're looking for. So once you calculate it not to be that, you then have to switch your left or your right, right? And then after that, when you try that right minus left again, it won't necessarily work in the same kind of way. You'd have to add it to the left value in order to get you know what I mean, to get the distance to the mid.
And the one with the plus, it works for both, either in the start or in after, like later in this one.
Absolutely. The one with the plus is probably the best one you want to use because it just works regardless of the fact that the left or the right is moved.
Okay, so like I'm gonna just write in chat the both equation, just someone like still trying to understand what we're talking about. So there's this equation and there's this equation. So there's these two, right? Oh wait, let's make it. So
Yeah, the one
there's
at the
two.
bottom.
So now we're like asking which one it work. So if we said that R equal index 3, right? And L is equal to index 6. Like let's try to apply this both equation. Like if we see the array in front of us, the middle is either 4 or 5, right? It's either 4 or 5.
Absolutely.
So if we did if we like apply this, it's gonna give us what, 8, 6, 7, 2. It's gonna give us what is that? 4. And the other one, it's gonna give us what? Someone help me, please, Matt. It's gonna do okay, 3 minus 6. Oh god. Yeah, you figure it out.
6 minus 3. 6 minus 3 divided by 2, because it's the floor 2, it's going to be 1, right? Because you're not taking the decimal into consideration. And then after that, you'd add that 1 to, which would essentially be the lower value, right? Your 3 would be the left, so it would be 3 plus 1, which will each equal 4 as well in that particular scenario.
Okay.
Yeah, I get it now.
God bless your brain, Ningas. Okay, let's continue. Now we understand how to calculate the middle. I think this will help us a lot later because, like Shazza said before, some algorithm or like some problems, you will have to adjust how to calculate the middle. Shazza, you still with us?
Okay, yes, I'm with you. So we will focus on this way. Do you agree on this? Right plus left?
Yeah.
Yes, right plus left. Okay.
Yeah, there's this one and there's another one. But maybe we go with this one because it's simple.
Okay. Okay, now we have left and right, then the middle. So we need in the first and for every moving of right and left pointers, every time we need to check if the mid is the same as the target. This is the happy scenario that is the middle is the target, and so we will return and say, hey, we got the target, it is in the index of middle. This is the happy scenario. But what if the target, maybe we have two scenarios. Okay. The first scenario is when the let's say here is the middle is 3 and the target is 10. So let's say that we have here is the middle is larger than the target. What are we going to do? We here need to adjust our pointers. Median is we said it is 12 at 3, right? And the target is 10. So we can, which pointer we need to move?
So
we calculate again and complete ourselves.
we're gonna need if the target is less than the middle point, we are gonna need everything after the midpoint is irrelevant. So we remove the right pointer to mid minus one, the element right before the mid.
Okay, I remove.
So right now, right will be at index 2.
Here. Right.
Yes. And we recalculate the midpoint again.
Okay, so.
Okay, can you tell me like why we did this? Because what's the reason? Why we did?
Right now, the target is 10. 10 is bigger than 12. 10 is less than 12. And every element after the midpoint is bigger than 10. Because it's
so
so everything can just eliminate it.
Okay.
So we moved the right pointer to be just less than the middle. So we have here the left still at 0, right at 2 index. So we have to recalculate the middle again. Here is the middle, will be with the same equation. Here right will be 2, okay, plus left, which is 0. So it will be 2 divided by 2, so it will be 1. So we will move the middle into index 1 here, right? Is this correct?
Yes. Now we see if the middle equals the target. The middle now is less than the target. It's 5, and the target is 10. So we shift the left pointer.
So we need to move the left.
Will be plus 1.
Wait. Okay, come on. To the middle plus 1. It will be here.
Then we recalculate the midpoint again.
So left and right.
But do we need to recalculate it in this particular scenario when the left is equal to the right?
If the left is equal to the right, we can just check if the element in it is the target or not. If it's the target, then we get the target. If it's not, then it's not in the array. The element we target is not in the array, I think.
Absolutely.
Wait, I didn't understand this part.
Sorry, how did you move the left from 0 to 2? I'm trying to understand that.
By doing left, okay, equal middle plus 1. So he will come from here to the middle plus 1. So he came here.
Oh, okay, yeah.
Now the situation is left and right pointers both pointing to index 2. What are you going to do now?
You can check if the element is in index 2 is equal to the target. If it's equal to the target, then you have the right index. If it's not, then the target is not in the array at all. Let's say the target is 11.
But the comparison each time is between the middle.
We can recalculate the middle. The middle will be index 2 because the left is 2 and the right is 2. So 2 plus 2 equals 4.
Yeah, it's 2. Correct. Correct. Because the target is actually 10. So I think that's it.
Like this?
So after we move the left target, we maintain the right one.
Yes, we didn't do anything with the right. We only move one pointer at a time. If it's right or it's left, we don't move both.
Yeah, the confusion may be in the last.
We have 3 pointer, left and right and mid pointer. We only move 2 and 1 remains the same. Every time we remove the right or the left and we recalculate the middle. But if we remove the right, the left remains the same. If we remove the left, the right remains the same. And we recalculate the middle.
So the movement depends on if it's less than or greater than. So you know which pointer you're moving. I guess I'm correct. So if you compare with the middle, you know which one you're going to move. Is it the left or the right? It depends on which one is greater and which one is less.
Yes.
Okay.
Yes, because it doesn't have an if statement going in.
Your mic a bit like muffled. It's hard to understand.
And so yes, you need to check if what you're looking for is the correct answer. Because if you don't just do the calculation only, you don't use an if statement, then it's going to go
It's still a bit hard to understand you. Maybe your network, maybe you can write in the chat and they will read it out loud. If like everyone understand this, we can move to the code. But if someone still have a question, even if something like very early you didn't catch up with us, you can freely ask, and we will explain to you again. I sometimes forget everything, so don't feel like you are not belong here.
Let's move to the code. By nature of coding, we will go again through each step so we can rehearse the whole process again. What do you think?
Okay, let's jump to the code.
Okay.
You wanna code it or you wanna?
Can you go for it and?
Okay, I will share screen.
Okay.
Or if someone else wanna code it, Ningas, you wanna code it, or maybe Fatbu. Okay, I can't read this name for some reason. Anyone here wanna code? Just write it in chat. You're not gonna code it alone. We're gonna code it together.
Sorry, bro. I'm on my tab.
Yeah, don't worry. Okay, I do share my screen. I'm just encouraging everyone, like, if you wanna code.
So can I say something, Musib?
Yes, go.
Is it possible for you to, just for learning's sake, if it's possible, like you might decide to ignore it if you don't want it. I mean, instead of us using a sorted, let's use an unsorted array, then we sort it, then we can now do the binary search. What do you think?
Yeah, we can do that. We're just gonna give it to a sorted function, I guess. Right?
Oh, yeah. Exactly.
Yeah.
You're right.
Okay. Where I am.
I mean, when you do sort, you have to actually know whether it's sorted in ascending or descending.
Yes, go ahead, please. Can you repeat? Oh, there is that part about ascend. So like there is this one. So there's this one, right? The first one is gonna be about like normal search, a sorted array. We're gonna search it like we did in, but this one is gonna be a bit tricky because this one is not fully sorted. And let's hope we do it together again. So I'm gonna jump to here, and I'm gonna type. You guys do the coding. Okay, let me move this window. Or like let's read first the problem. Let me move Discord to other screen. So we choose Python, I guess. Given an array of integer nums which is sorted in ascending order, and any integer target write a function to search target in nums. If target exists, then return its index. Otherwise, return -1. Okay, so we return index. We didn't find it, we return -1. You must write an algorithm with O log n runtime complexity. So in this case, we have this array. Target is 9. Okay, so some reason. Okay, so can you just send Excalibur picture or something, just so like we keep it in like the Excalibur picture that we draw. I can't hear you.
This is done by export image. I didn't know.
Yeah, I think so. Or just take screenshot and post it in Discord.
Okay.
So how are we gonna do this? So first we have, let's declare our pointer. We have first pointer maybe. corresponding first.
We have to declare left and right. Left with 0, right with
Okay, left
nums -1.
0.
Yeah, the right is the length of the array minus 1, something like that.
Len num -1.
Okay, while -1 not just
Because the index len usually gives you the number of element in the index, but the index start with 0 from 0.
okay, I see. So -1.
Then you
And
do while loop, while left minus or equal right.
okay,
Less than or equal right, I guess.
okay, but why? Why?
As long as the left pointer is less than the right pointer or equal to the right pointer, you're in the boundary. If the left exceeded the right pointer, then you get over it. This is not how you want to calculate. In this, look at the picture. As long as left less than right, you are right. In this, if you didn't, if let's say it's 11, you wanna it's high. Do you get what I'm saying? Because I'm not.
So wait. Okay, I'm with you. So we have left pointer and the right pointer, yeah?
Yes, you will get the middle in between. So every time you change the left or the right, you recalculate the middle. The middle is between the left and the right, and or could be equal the left and the right.
Okay, so we are gonna do a while, right? Okay, something gonna keep looping.
While left less than or
left
equal.
This one less than this one. So
Yes.
it's like we so what we're saying then is like, okay, keep up a loop that's gonna keep looping until this left go out of range, right? That's what we're saying.
You will okay. It could be if
because this is left and this is right. So we're like saying keep looping until this one go out of range.
Until
Can't we use what the Shaza the way she did the whiteboarding? I think it's when right equals to left equals to mid. That's it. I don't know if I'm wrong, please.
Wait.
But that was what she did, right?
Okay, so this is
so while is not equal to while the right is not equal to left is not equal to, okay.
Let's say if in the array I am looking for 12 and 12 is the middle. So why do I keep going? It's already there. I already find it. It's a first try. I always check the middle. So I don't check the left and right. I check always the middle.
Exactly.
Okay, sorry. So my brain is very slow, so bear with me, okay? So I'm just asking, we're gonna do while, right? Now in this while we're gonna write condition. I just wanna imagine it in my brain, like when we're gonna do while, something gonna keep looping, right? We're gonna just keep looping until a condition happen. So like in my mind it's like, okay, go sir, keep looping until this condition happen. Now I want to know what is that condition. Now we have, okay, how we can do this? We have two pointer, right? Let me remove this. I hope you guys following with me. So we have this pointer on the left and we have this pointer on the right, right? Left and the right. So this is the two that's gonna be right in this condition, right? Either I'm gonna do like left, maybe less equal than right, but what this mean? What does it mean? So I think it's mean this less than this. So when this one right here, so as long this one is less than this loop gonna keep going. So if this keep doing like this, the loop is gonna keep going, right? Or equal. If it's here, the loop is still going. But if it is go right here, then the loop gonna stop.
Okay, right? Let's say the target in this picture, the target is 11, not 10. So the target is not in the array at all. Right now we looped till the midpoint, the left equal right, and the midpoint is 11. What are we gonna do according to the condition? We didn't find it.
We're gonna return -1.
Or decrease the right, according to which one in the if condition is first.
Wait. Can you repeat that?
Stop left and right in index number 10, please.
Okay, 10. We don't have 10.
In 2, index number 2. Yes.
Okay, 2.
Here and right also is here, and the middle point is here. Now.
Okay.
Now,
Okay.
both pointer are here, but we did. This is not the target. The target is 11.
Yeah, but
right?
we have equal, right? We can do equal.
Yes, I know. But they are equal. So we are searching in this index. Right now, the middle point is 10. So according to our if condition, we will either increase the left or decrease the right. So either way, so increase the right. Let's say
this one never gonna happen. This condition.
No, why is this never gonna happen? If
it's gonna happen.
Yes, if the target is not in the array.
I don't think this can happen.
If we are looking for 11, 11 is not in the array at all. 11 is not in the array. So we will incriminate
oh, okay. You mean if this here in the end? Yes. Now I see it. So if this, oh my God, this is gonna make me. Let me move this right there.
So if we're looking for 11,
oh, you're right. Okay,
we are not gonna get going.
But if this one is already here, right?
Yes, and let's say the midpoint is 2, so the right we will decrease.
I have a question.
Yes.
I have a question. Why would they give you to find something that does not exist in the array?
So
why is that? Why would it?
They're asking you to search. It could exist or it could not exist in the array. You don't know.
That's what I'm saying. That is an edge case. You can handle it. Like you can check to see if the number even exists in the first place, right?
Okay. Let me say something. So what I was thinking is this left case can only go right here, and this only the while loop can only stop if this go here. But what Manitila explained to me, and she has right, is this is not the only case that the loop can break, because maybe we are looking all right here, and this is common. Maybe this is coming from this side. Maybe this is the one that's moving, because at the start we don't know which side we're gonna start, right? Because you see that we did this line right here. Maybe this line gonna be right here, right? So we're gonna start with this one, with this, right? So this gonna keep coming, and then gonna reach here. Then if this come the last station right here and didn't find it, we have the condition that we did middle +1. There's other one gonna be -1. So this one gonna jump here. Then the loop gonna stop. Then we're gonna return -1 because we didn't find it. Right, Manitila? Is that what you meant?
What I meant is if we are searching for an element that is not inside the array at all.
Yeah. So it's possible to cross this side or let's cross this side.
Looking for 0. 0 is not in the array at all. So we will keep going left. So yeah.
Okay. Maybe I confuse you guys. So please let me know.
This is check will be
yes, I'm very confused.
The left in index 4 and the right in index 3 will return loop break loop. You understand?
Okay, left is what?
If left يعني I explain the right and the left the right and the left move move مع بعض.
You can speak Arabic, it's okay.
Yes, بيتحركوا مع بعض الرايت واليمين والشمال بيتحركوا مع بعض جوه الاري. لو الشمال عدى اليمين كده خلاص لازم اللوب يقف. يعني انت حرك دي شمال، حرك شمال مثلا وديها عند 3.
Okay, move left to 3
مثلا، واليمين وديها عند 2.
and move right to 2. Okay.
بس كده الكونديشن يقف او اور مع 3 برضه لو الاثنين مع بعض في نفس المكان الكونديشن يقف.
لو الاثنين مع بعض في نفس المكان انت لازم تشوف هل المكان ده فيه الحاجه وفيه الكونديشن اللي انت عايزها ولا لا. ما هو ممكن المكان ده بقى الميدل دلوقتي تلاقي فيه ال10.
الميدل فوق الشرط ده، الميدل فوق الشرط لو الميدل بيساوي التارجت هيخرج بترو، انما تحتيه الشرط بتاع الفولس اللي هو لو الاثنين بيساوي بعض هيخرج فولس.
انت كده بقى عندك كذا كونديشن، انت حاول تصغرها، حاول تصغرها ما تكبرهاش قوي.
Okay, let's not switch this to Arabic, please. Let's come back to English. Okay, so this is confusing, and it is my bad. I don't understand quickly, like you guys. So I take a lot of time.
Can I ask a question, please?
Yeah, go ahead.
Can I ask a question?
Yeah, go ahead.
If an element does not exist, then what happens? Do we return just nothing, or
they give us something? If the element is not exist, return a specific index or something, like return -1 or return. So I think
exactly. Python already has. Python already. Yeah, exactly. Python already has a very short one-line code. You can just check and return -1, right? Musib, am I wrong, please?
I think it depends on the here in lead code. If the target exists, then return its index, or otherwise return -1. It depends on the problem.
Okay, first let's take a deep breath. Okay, let's relax all of us. This was a stressful, like we're studying now for maybe hour. Okay, let's take a deep breath. Oh, okay, everything's fine. Relax. We're gonna answer this list code. We're gonna have a good night and we're gonna go sleep. Everything's gonna be fine. Okay, so while loop, right? Come back now, don't sleep. So while loop, we're deciding what condition we're gonna do here. So we're gonna start with left, right? Left. Or let me go back. So left, less or equal, because at the start loops need to start, right? So what is the condition we have? Is less than right? We can do that. We can do
less than or equal to.
Less than target.
Left less than equal right.
So my question was not answered. I don't know if you understood my question.
Okay, you ask if the element is not found. Okay, so let's see this process. So they are saying, okay, look for this area.
What I asked is why do you have to go into a loop when you can just check with an if condition and return -1? That was what I was asking.
Okay, so like if condition h1, like just go h1, like you go one by one.
There's always a one-line statement to just check.
Let me just answer that. You are asking if why you have to check, why you have to look use binary section. You can just do if target in array, right? Is that your question?
Exactly. Yes. Why can't you just do that and return? Why?
That's your one line of checking is O of n. That's why. So that's why you have to
understand the question.
Is asking why you have to check if a value exists in an array with binary search, right? Because there's a possibility that the target value is not in your array, right? But you do binary search all the same.
Yes.
So you can just check using membership operator, right? If target in array, right? And I'm telling you that one line of code is O of n. For you to check if a value is in an array, is O of n.
No, if it's not, I mean, if it's not in the array, why not just return 1?
Yeah.
Why would I have to go into a loop and start checking each and every and doing
that's
the calculation?
That's what I'm telling you. It is faster to use a binary search than to use that line.
Okay. All right, that's fine.
Okay, so did he answer your question?
No, it's fine. I get.
Yeah, the assumption here is that you don't know what the elements of the array are, right? So you have to walk it, right? but the benefit here is that it's already sorted. So if the array is sorted, this is perhaps the method you want to use to prevent yourself from doing O of n, having to go through each one of the elements to figure out if it's actually there. Because it's sorted, you can then take advantage of something like binary search by dividing your problem into two constantly. You get that log n, how to say, complexity, which is far better than having to go through the entire thing because you're constantly dividing the problem into two. And then just to answer Mentala's, or just to just to go over what Mentala said, essentially, if the left part of the array is greater than the right part of the array, that would be exceeding the boundaries of your partition. So you always want to ensure that the left is either smaller or equal to the right, because if the left exceeds, or it's an index greater than the right, it would mean that you've covered that particular section where you thought the target may exist, but it doesn't exist there. So you might as well return a -1. Reason why you're turning -1 as an index is because you know your array start from 0 to a certain specific number. So if you return a negative number, you can be certain that there's no index of that particular number in most languages. But you know Python, you can use the negative numbers, but in most languages, that negative index number means that it doesn't exist in that particular point. It's something similar to C when you return a -1 in an error condition.
Hello guys, can you guys hear me?
Hello, yes, we can.
Like, I don't know if I can help to explain this problem because
Yes,
I
go
don't know. I
ahead.
just feel like I can. I don't know. Can I share my screen?
Okay, if I can ask, what do you wanna show?
It's like I just want to explain this sorted array in a way that people might understand it better.
Okay.
Like this,
But
but
we understand it already now. I think we understand it already.
Yeah. Okay,
Okay.
either you join late or something, because we do understand array, but I think we were like kinda trying to understand what condition we're gonna write here. Then Pascal asked like about the return -1.
Okay, it's okay. I was thinking that maybe this statement here, while left is less than or equal to right, was not clear. So I wanted to explain it.
Okay,
But
you can
since
go ahead and share screen and please explain.
okay, thank you. Let me share my screen. Cool.
Me. So
I
let's
think
follow what Shaza right here, because I think I'm gonna make it more complicated and probably gonna make you mad, guys. So I don't wanna make
I
you
think
mad. Let's keep going.
Nux,
Yes.
I think our only problem here is that we didn't whiteboard a particular example when the target isn't there.
Oh.
I think if we had whiteboarded it when the
Oh.
target doesn't exist, it would have been extremely clear as to why the left needs to be smaller than the right.
Okay. We can do it. We can try do it. Let's see. So.
I know Mentella gave an example of when it's 11. Your target could just simply be 11, and you just follow the same steps, and then it would be extremely clear as to why the left always has to be smaller or equal to the right.
Okay, Shaz, I'm sorry I'm deleting this stuff, but I did make a copy. Okay. Okay, so we have this drone. So 11. Let's do 11 is the target. 11, right? Now let's say this is left pointer and orange is right pointer. Okay, what is the middle? The middle gonna be 6,
6 plus 0 divided by 2.
Okay, middle is 6 plus 0 divided by 2. It's gonna be 3. Okay, this is the middle. Okay. Okay, now we see. After we verify the middle, what is, let's do also pseudocode because we can later just transfer that pseudocode. So the target is 11, looking for it, and the pseudocode first we decide. Okay, let's check for middle. 6, 0.
There is no value 11, by the way.
Yeah, so like we're looking for 11, so we see how this pointer gonna react.
Oh, okay.
So we find out that the middle is 3, right? We point the pointer there. Now the next steps is
to check the value of the middle if it's equal to the
okay,
target.
so check if mid equal target. Okay, it doesn't equal 11 and 12. Now we're gonna check if the middle with the left, if it is like with the minus.
Checks are usually 3 check. If the mid equals the target, if the mid less than the target, if the mid bigger than the target.
Less than target.
It's 12, the target is 11, so the mid is not less than the target. So we remove
this. Okay, so middle is 12.
Condition. We don't enter this.
So this is not
the one to the
left. So we're not enter this. If middle less than target. Actually, no. The
middle is greater.
We will enter the above condition.
So this is true.
Yeah, that's correct.
Okay, so now if
the target is 11 and the
so this is target.
Yeah.
Oh my god. Okay, let's just skip it. Okay, this is the target.
So if the mid is bigger than the target, the left pointer will remove the left pointer to be mid minus 1. So eliminate all elements above the midpoint.
Okay, so first we check this value, right? Middle.
Yes.
And we compare it with this value.
Yes.
And now we found out that the middle is greater than the target. That means this element, the target, is right here in this side.
Yes.
So the right will equal the middle.
Okay, so if this target is in this side, that means my right here need to move to here, right?
So minus 1.
So to move this here, I can do
will be equal.
I can do right equal to. I already have the middle, so I can do middle minus 1.
Yes.
M minus 1.
And
so
you have
I
to
suppose
do for the first check, you have to do left equals middle plus 1.
Yes, the first check. If the first check is correct.
Wait, I didn't catch that.
You have
if the check
empty condition. The line before the if.
This one?
Yes.
If you
No, the line before it.
This
Go
one?
up. Yes. Don't raise the condition in here.
If so the target was greater than the middle value.
Okay, but we're working in this case.
Yes, but we have to work for all cases.
Let's do it for that too. So we need to change something that will work. Let's say 13. Okay.
Let's say step 13. By so right now enter the while condition again.
Okay.
We recalculate the middle. So the middle.
Wait. We're gonna keep. So we wanna work on this condition, right?
Yes. Okay.
Okay, so we're gonna keep everything the same. The only thing that change here is the target. So instead of working with 13, of 11, we're gonna do 13. So we make this condition true, right?
Okay.
So in this case, we have target 13, and the middle is 12. So it is true. What's gonna happen? Okay, let's see.
Left equals middle plus 1.
Yes.
Okay, so the middle is 12. Okay, and the target is 13. Now 13 is bigger than 12, and because this is sorted, 13 can never be here. So it must be here. So if it is right here, that means this right pointer is in the correct place, but this one is so far. So I need to move this one right here. Why I don't move it right here? Because I already check the target with the middle in this condition right here. So I don't need to check it again.
No, I don't think that's how it works. You're gonna just
We're
decrease
gonna move
it by
this
1.
right here, right?
No, you're gonna just decrease it by 1, and then the loop is gonna go to the mid, and it's gonna again divide.
Which one that I'm gonna decrease by 1? The left?
The left, yeah.
If I
Then it's
decrease by
gonna
1, it's gonna go outside the range.
no,
No, it can't be the left.
go to
No, you have to increase it.
increase it, Marvin.
Yeah, so I think left is gonna be called middle plus 1, right?
Yes.
No, it's gonna be left plus 1. Then
No. It's going to be mid. Because remember, you're checking. The first thing you do is you check if mid is equal to the target, right? After you calculate the
what's
mid.
gonna happen is gonna go left plus 1. Then the mid is gonna again calculate the left plus the right divided by 2. Then
Yeah, you'll do that in the next iteration. The only point he's trying to make here is that if there are 2 conditions, I mean there are 3 conditions you're testing, right? In each iteration of the loop. First, you're checking to see whether or not the mid is equal to the target, i.e. you found the target. If you haven't found the target, then you have to check whether or not the mid is greater or smaller than the target, right? If the mid is smaller than the target, it would mean that the left needs to change because you can disregard one section, or at least half of the array. And then if it's greater, you can disregard another half of the array. But in the particular case when it's less, the left needs to change. The left is going to be equal to mid plus 1 in that particular case. But if the mid was greater than the target, as they wrote there, the right would be equal to the mid minus 1.
Yeah,
so
that's correct.
Yeah, exactly. Because we want to.
And then
if mid is equal to the target, then what happens?
Plus 1.
Then you found your answer, and then you can return it. If the mid is equal to the target, you found your target.
Okay, let's do this one. That's a good question. So return middle, right?
Yes, return mid.
Okay, that's a
And
good question.
just one little thing. It's not if, it's if else. It's either or.
Okay.
Then yes.
Yes, I wrote it in the shop.
No, this one is if because it's return it doesn't matter. One is else.
Yes, if else. Exactly.
Or else because Python, right?
So this one is if. No, this one is if. It doesn't matter because it's return. Return it doesn't matter if you have.
Okay, if else.
Yes, this one is else.
Okay, so everyone understand why this m plus 1?
Yeah.
Okay.
Yeah, I understand, yeah.
Okay, so m plus 1, that means it is right here. But let's, do we continue with, I guess they're both, let's keep it 13, because it's gonna move the same for all of them. So this
yeah, it
one
works
did move.
either way.
Yeah, so this one did move right here. Now, we're gonna loop again, right? And we're gonna calculate.
We are going to get a new middle.
The right and the left. This time, what is the
4
left?
plus 6 equal 10. Divide by 2, then it's 5. The middle is
5. Exactly. Yeah.
Okay, 5. Then check if middle target equal 5.
It's 4.
It doesn't. Then I'm gonna check if middle, this one, is less than the target. It is not. this is 17 knots. Else if mid, wait, if it not, right?
Yeah, it's not. It's not.
Okay, so else mid greater than the target. Yes.
Yes.
Okay, here we go again. R equal m minus 1. So m minus 1. So this one R gonna move.
To point to where L is.
Gonna move to m minus 1. So now I have this bot checking this target.
Yes.
And then
We loop
then I'm
again.
gonna loop again.
Again, yes.
Yeah.
No, but wait.
Yes.
We should stop the loop from looping because we passed the target.
No, the target is
No,
less
no, we are
than.
going to loop again. Remember that left
Ah,
must be
yes.
less than or equal to right. Left must be less than or equal to right. So we are still.
We still have one more loop to go.
Yes, we still have
Because
one more loop.
Yes,
We didn't
one more
check
loop, yes.
Yeah, we didn't check this number right here.
Yes, we haven't checked this element yet.
So this move right here, and what happened to this? We're gonna calculate again. So
Yes.
4
Plus
plus
4
4
by 2, so it will be 4.
4. Then the middle gonna jump to here. So all of them checking this, and this is the last case,
Yes.
right?
Yeah.
So
Then
this
it's
is the
gonna do
condition
check.
which we're gonna use.
Can you repeat?
I say this is the condition we should use to exit the loop.
But we
We
didn't
already
check.
have a
Maybe it's
condition.
equal, right?
We already have a condition. The condition
Exactly.
we have
So
is
this
that
condition will
when
check
left
for the
must
minus
be
one.
less than or equal to right.
I'm talking about
The target could be 15, not 13. So maybe we are searching for 15. So maybe this is the target. We don't know. Maybe the element in the index 4 is 13, not 15. We don't know.
So
But
we
if-
need to
what
check
if-
these
Well-
3 cases. If there are 3 of them false, then
one
we're
sec.
gonna return minus 1. Yes, yes.
Check the chat. I wrote it
Okay,
in the
let
chat.
me see. So,
He's technically right. The condition where left is equal to right should be the condition for. It can be the condition for breaking the loop and returning a negative one. So you could do if left is equal to right, and the index of left and right is not equal to the target. It would mean that it doesn't exist, right? So then you could break the loop at that particular point. But that said, the way that you've
else
written the
I-
pseudocode as it is, it will work regardless. But you're absolutely right. At this point, this is a critical point where you have only one element and the left and right are pointing at the same place. It would mean that either the target is equal to what the left and the right and the mid are pointing to, and if it isn't, then it essentially means that it doesn't exist. It'll be an element of one array, and if that one element doesn't have the target, then it would mean it doesn't
smart.
exist.
Yeah, now I see it. Okay, that's smart. So there's no need to check, right?
No, it's necessary to check the
It's
last
necessary
element.
to check. You must check that the element is equal to the target, but
No, I mean
it's
like
essentially
there's no need to check for all of this. We can stop the loop in this from the beginning.
No,
when we move this right here,
If you
we're
stop
gonna check it with the target. If there's like 3 of them pointing on the same element, it means it is the last target, right?
Yeah, it's
Last
the
element.
last target. Last check.
yes, it's the
Yeah, I
last
think
thing to check. After
if
this, there's nothing to
it's,
check.
Same thing with the rights, or same, yeah. You can
So, like,
just
if
check them. With
Yeah, if there are
minus 1.
3 of them on like have the same value, then they don't equal target, we can stop. Okay, so now in this case we're gonna check this one. Equal targets no, tit, then what's gonna happen? Return.
-1. That's it.
Okay, so I guess it's good to start with designing pseudocode for a case that doesn't exist, so we understand the bot. Okay, let's keep going. What we gonna do here?
But like before that returns, remember we're just trying to clarify why left must be smaller or equal to. If we didn't have that returns -1, right? What
This
would
one.
mean what would that mean then? It would mean that because it doesn't fall into any of those if conditions, it would probably go into some kind of perpetual loop, right? Where it's constantly checking the same element over and over again, because the left and the right wouldn't change at that point. It would just be the same thing over and over and over and over and over again, right? So that's why we need to constantly check that condition, or else we'll just fall into something that's undesirable.
Okay, so now we start with the middle, right?
Yes.
So R plus L2, then check if
Remember the brackets, yeah?
yes, correct. Okay, why the bracket? Just someone
Operator precedence.
because priority for divide.
Yes, your operator precedence. I forget what it's called. Is it BODMAS? Where multiplication happens after division or something like, or division happens before multiplication.
BODMAS.
Okay, mid. Then L equal mid plus 1.
No. The left, yes, it's true.
It's nums. Remember, it's nums. You're checking the element, so you're doing nums square brackets mid. If that element is equal to
target and mid plus 1. Else.
Remember
else if to the second
yes.
elif, yes.
Wait, is elif?
Yeah, else if mid is greater than target.
Should be just else, because you already have the if the middle equal target. Where is the middle equal target should be the first condition. If mid equal, if nums mid equal target should be your first condition.
Okay.
Before if and everything else.
So it should be if nums mid is equal to the target.
After
the
mid,
first
after
one.
mid, we just
And then else if nums mid is smaller than the
you don't need
target.
this if it's end in return, because if this condition return it will break everything. It will get out of the function.
Absolutely.
Wait, I
I
forget
think let's
something.
allow one person
After the
to
you
give
just check
his
if
solutions. We can.
Okay, I forget this one.
Yes, what Mentala said. If nums mid equals target, that would mean that you found the target, so you just return the mid index, yes. And because it's like that, you don't need to put it in else if and then else block.
Okay, and then mid minus 1. Mid. And return minus 1. Right?
That's correct.
Okay.
Sorry, where is the greater? Where is the greater than? Okay, greater than is above. Where is the one for greater than?
This one
is else.
It's else.
Okay, the else. Okay.
I guess, yeah. I guess if they are not 1, then it... Okay, let's see. Please work. Don't tell me after all this hour we give it wrong. Okay, clap for yourself, guys. You solved this amazing list code. Okay.
Congrats, guys.
Now we understand how it works.
Because sometimes you get accepted, but there is an edge case that you are not destined for. So I usually just try to submit, not just run, because
submit. Okay, let's submit.
Does not usually work.
Okay. Oh, we beat 9. Okay, nice. Okay, now this one we understand it. I think this one's gonna be easy, right?
Can we add an edge case that does not exist to test it, like the one that does not exist?
Let me reduce. I believe from here, test case, then okay, suggest some cases. Do we change the targets in the same array, or we change everything?
I just changed the target.
Okay, let's do choose. Maybe it doesn't exist.
Let's try 11 or 13 or 15, anything you want.
11. I think 2 doesn't exist because
Yeah,
doesn't
2 doesn't
exist.
exist.
So 9 is in the right side. Let's do 1 in the left side. Let's do -1. Save. Done. Okay, correct. Index 0. Okay, we are all good. Congratulations, guys.
Congrats. Yeah, nice.
I feel proud. I understand. Okay, this one.
Everyone.
Let's see what they talk about. So search in rotated sorted array. There is an integer array nums sorted in ascending order with distinct value. Prior to being passed to your function, nums is possibly rotated at unknown pivot index q k such that the resulting arrays blah 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 0 index. For example, this one might be rotated at pivot index 3 and become this one. Okay, and given the array nums after the possible rotation and an integer target, return the index target. If nums, so the same. If we find the index, we're gonna return index. If not, -1. You must write algorithm with log n runtime complexity. So in this case, they're looking for the same. Excuse me, but let's see. This array is sorted, right? But the one we're gonna work on right now is this one. Notice there's like two.
It's sorted, but it's made in half because some portion of the array will be bigger than the other, but it's not all of it.
Yeah, let's take this one and let's go to right here. Where is x gonna do? No. Okay. So we're gonna do it here. Okay. So this is our array. So we notice something is 4. So here is the other side from it. So this is where it's pivot. Like, yes, go ahead. Someone said something.
You deleted the last solution?
Yeah.
I want to again, please. Wait.
Okay, I would take screenshots. I will paste it in chat.
Okay. Thanks.
No. So in this, what is difference is the old one, like we deal with sorted array. This one they're gonna give us an array that's sorted, but there is like it's different, like it's pivot. So how we can do this? Let's not lose our confidence, okay? And let's just say we have one pointer here and one pointer here, right and left. Let's do them in different color. Okay, left and right. Okay, what is our target for this one? Target is 0. Okay, so target is 0. Oh, this is gonna be fun. I can feel it. Okay, so um, mm, we need to calculate the middle, I guess.
Yeah,
But
let's imagine
but
that we are going on the same process.
okay, same process.
It's basically the same process, but it's different. There is a few extra condition because if it could be lower, but it could be higher. It's a bit. If it's higher, if I'm looking for 8, if for example, I will remove my left and keep going. But I know if it's higher, it cannot go like to the left. But it's if it's lower, it can go left on right because I know there is a pivot. So
That's a good. Yeah, that's a very good idea because what was the? Let's come back to the other one. Wait. Let's come back to this one. Sorry. Wait, where I am? Okay. What was the thing that told us to search in the left or the right? Because we know it's sorted, but this now we don't know. So we need to add a check because before when we do like we made 2 pointers, 3 pointers, and then we check what we did check right here. When we say the middle less than the target, automatically we know, are we gonna scratch this one or are we gonna scratch this one?
If the middle is less than the target, we know everything below the middle. We're only going to the right.
Yeah.
So this, if the element we're looking for is bigger than the middle, it's easy. It's the same. But if it's less, then there is a problem because it can go in the left or in the right.
Yeah.
So we have to check it against the element in the left and see if it's okay.
Okay, that's good idea.
We check it if we know it's only between. Let's say we're looking. Okay, can you give me the example again? And go.
Okay.
This the example. Okay.
0.
Let's say we're looking for 8. We know 8 is bigger than the middle. The middle is 7. No, 8 is bigger than the middle. So we are only gonna go right.
Okay.
So the left pointer, we remove the left pointer, the mid -1, and we see if it's not but let's say we are searching for 2. Right now, we will check 2 against the left.
Okay. I'm gonna be honest with you. My brain speed is very slow, and you are smarter than me, so you are running ahead. I'm trying to catch you, but I can't. Please,
I
you're
am
slow to my level.
the ideas of my head before they go away. That's why.
Okay, so I have no idea. I'm lost right now. Okay, one thing I know is, and please, if someone have idea, please jump on the scene. I'm just comparing now this one with this one. What is the difference? I think the difference is here, because why this one was enough? Can someone answer
Because
this? I think because we know it's sorted, right?
No, it's sorted. The other one we sorted, but
this one we don't know.
No. It's sorted, but it's get rotated.
Yeah. So we're gonna check the middle.
Yeah, I get.
We're gonna check the middle, but we need, like Manitella said, you said this one, right? Because this one, we can know if it's sorted, maybe. We can know which side is sorted. Is that what you meant?
Both sides are sorted.
Okay.
But there is, okay, it's a different degree. Like one is higher than the other. Like, give me the other one, the one we did before. Yes. Let's say we want to pivot this around the two index. So we will take 2, 5, and 10, and we will
5 and 10.
12. Yes. We will draw a line between 10 and 12.
10 and 12.
Yes.
This one right here?
Yes. We will move it to after the 20. So we know it's sorted.
Oh, okay.
This is
so it is sorted in the beginning. Okay. Oh, okay. I see what you mean.
Sorted in the end, but it's different.
Oh, okay. So it is sorted. Yes, they did say that. I didn't focus
from the middle and
but it's split here.
Yes.
Okay, if I come back right here, yeah, I can see it's sorted 0, 1, 2, 4, 2, 4, 5, 6, 7. So I can then
but is this the only case, or there is another case which is not sorted?
so like they are all sorted as he
No,
said here.
the description of the problem say
Yeah.
it's a
Sorted but pivots. Yeah.
The question itself is search in rotated the
Sorted. Yeah. Yeah.
no
It's
get
sorted ascending order, and then
the problem
then
the title of the problem once
oh,
go up.
search in a rotated sorted array. Yeah, that's good. Okay. Now we know that this is sorted. What that mean?
I feel. What about if, like, what I'm saying here is based on, I'm not understanding what, I don't know who is the lady that's talking. If I'm getting it right, I think maybe we should rotate the calculation as well. I don't know. I'm just suggesting. Would that work if we rotate the calculation, like she was
move
trying
this
to say?
part right here.
But you don't know.
No, what I'm saying.
You don't know
what I'm saying. Okay, let's say we are searching for like 7, like let's say 7, and
is
the okay, sorry, let's something like 8. Let's say 8 or something,
8?
or something that is how will I explain it to you? Let's say we're searching for something, yes, something like this, and we get the midpoint, which is 7. We compare, right?
Okay.
So when we do the comparison, the calculation, normally we will have said, okay, since the target is more than the midpoint, right? The value there, that's, we should take the what's the calculation? Is it mid plus 1?
L
one, right?
plus R divide 2.
No, I mean if the mid,
if the mid.
Oh, okay. Let me copy this one because it's gonna be the same, I think.
Exactly. That's what I'm saying is, why not we rotate the calculation since it's rotated? That's what I'm trying to say.
Rotated
how?
Don't know the pivot. We are not getting the pivot. We're not going. We don't know each element.
We're blind. We don't see this. We don't see them, but we need somehow to know which one maybe to start.
The good thing is it's actually half. If you look at it, it's almost like half of the rotation was on, like, it's like split into half.
In this particular scenario, yes.
Yes.
It's a random pivot. So it could change at any moment. My question is there a possible way that we can find the pivot point in log n complexity?
I think that will add. I'm not well with all, but I think that will
find the pivot. And they want it in time complexity O log n because it's in the you must write algorithm with O log n. So we can do it in linear time on ON if we actually checked everyone, and in this way it will be easier to find the pivot, but they want it in O log n.
I mean, okay, so hear me out. If we divide the list, right, because to get log n is just to divide them in 2.
Yes.
And the condition for a pivot would be that the number after it is less than the number that's
Before.
actually at the, yeah. So if we kept on dividing it by 2, couldn't we then at some point find the particular point, as we did with the target, to find the actual pivot point, but in log n complexity time?
Okay, we found it. Let's say we found it. But then we will have to do another while loop to actually compare it with the target again. So I don't know if 2 O log n will give us time complexity of what?
It will be 2 log n, but in that particular case, right, the 2 is factored out because the 2 is a constant. So it's not really taking into consideration. You take the greater of the 2, which would be the log n. So it would evaluate to log n, if you know what I mean.
Okay, that actually could work.
I guess. Yeah, that's true. 2 log n is, if you evaluate it, it's almost like log n as well, to the power of 2. Something.
Okay, can someone translate what you guys talking about?
Okay, so we're going to leverage the same thing that we did with binary search, but instead of because it's not a sorted list, right? We're trying to find the pivot point, and the condition for the pivot point would be that at the point you're at, the element after the point you're at is less than. You know what I mean? Or yeah, less than.
Oh, so
because
like
it's an ascending.
okay, so but how do we choose the element?
But I think this will be harder. I don't mean to interrupt you because it if let's say the midpoint is let's say we start it's pivoted around 1. So let's say all the midpoint will be 6. We go higher, but we don't know if I don't know.
Okay,
Yeah.
wait.
Difficult.
Yeah, go ahead. Go ahead, Ningas.
I think he's right actually. I think he's right because if it's higher,
Yeah, this example is really easy because you only need to do it once. But if you to take your R plus L, right, divided by 2.
Let's say the one we did. Let's say divided. If it's a pivot is 1, so it starts 1, 2, 3 to 7, then 0 at the end, and we're
Yes.
searching for the pivot. So we will start from the middle and we go linear, or are we going binary? If we go
No,
binary,
we go binary.
okay, we go binary. So we'll start. It
So
will
the
be
first one, right, will be 7. It's
no,
really
it will
simple.
not
I
be.
don't.
Let's say, Monsif, can you show us
Yes.
an array from pivot with one pivot? Let's say the
Okay.
pivot is 1.
Let's change this one. So this one gonna be so like
Yes, 0
yeah,
at the end.
like this, right?
Yes. So
Yeah, that one is more complex. Yeah.
yes, make it a little bit. So if it's like this, and we want, let's do binary search on it and try to see if we can find the pivot.
Okay. Let's see.
You can't call it binary search, Mentala. You have to find another name for it.
Wait, what is this?
Its name is binary. Actually, I don't know.
Mantilla binary. Let's keep going.
Okay. So
Okay. So we do. Okay, we find the mid, right? The mid will be at the 5 point.
yes. Okay. Then it's
And then we check the condition. If the mid plus 1 is indeed greater than
if, bigger than or less than the midpoint.
it has to be less than, right? We're looking for that condition where it would actually be the pivot, right? So if
Yeah,
it's
less than, yes, it doesn't have to be equal. So 6 will be bigger than 5. Then what? Then we will have to find we remove the L to 6 and
Yes.
search for a new pivot. Search middle. Middle will be 7, and then compare 7 with 1 with 0, and we get the yes. We apply then we got the pivot. The pivot will be the very last element. So we
Okay, let's not forget there is many people with us. Maybe we should try to explain slowly because I am not following you guys.
One of you should help him write the pseudocode.
Yeah. Can
Okay.
we do that?
Yes.
Is this can work? Is this can we modify this?
We can get the pivot this way. Then we sort it, and we do a binary search. We get our points.
Wait,
Then
we sort this again?
Yes, I think we will have to sort it actually.
But if we sort it, we're not gonna solve the task.
No, actually, we can solve the task because if we found it binary search, then add the pivot to it, we know the location, right?
Yes.
So
This is
sorting not gonna affect it?
No, it's not. It's not sorting per se. But what she said is, once you found the pivot, right, you can then adjust your traditional binary search in order to compensate for the fact that the pivot is somewhere else. So you then essentially, you know what I mean? Instead of pointing, number 1 will then be the last one, and then number 2 will be the first one, and number 3 will be the first. You know what I mean? Based on what the pivot is, you can then. I think it will be a modulus actually, but I'm not too sure. But let's just discuss how we'd find the pivot, the pseudo code. Sorry for finding the pivot in the log n manner.
Okay.
So the logic here is first you find the mid, right? The first line is cool.
Okay.
And then once you find that mid, the condition for it to be actually the pivot point would be that the element or the mid plus 1 is, how to say, less than the mid. That's how you'd know.
The mid bigger than mid plus 1. If num mid bigger than
bigger than
this is if condition.
It's an if condition.
Mid will be mid plus 1. So you compare the mid
okay,
will be
if mid
bigger than mid plus 1.
Mid plus 1.
Then you found the then your pivot is mid plus 1, but right now it's not mid, it's nums mid plus and nums mid plus 1, not mid.
So,
if in the condition no in your if condition, yes, it's nums mid plus 1.
But what about if the right is less than the mid is less than the right minus 1? It's gonna
We're
be
not
the pivot.
looking for the target here. We're not looking for target. We're looking for the pivot. No,
Yes, the pivot, because if,
the square bracket.
but
wait.
what if
Mid
the
like
pivot
this?
is-
No, Monsif.
She means the index of the array. So it'll be num square brackets mid plus 1.
Nums. Like this?
Yeah, square. No, all of it in square brackets mid plus 1. So mid plus 1 is in square brackets.
Oh, okay.
Like an array. And then to answer you, my friend, in this particular scenario, the first step is to find the pivot. So we're not trying to find the target. We're trying to find the pivot in this particular case, i.e., where the list actually begins, where the smallest element is, because it's in ascending order, remember. So they have to be greater than each other. So at the point where the ascending order is broken is the point that you'd find the pivot point.
Because I say this because to avoid to avoid the condition, if the last element in the array was the pivot, we're gonna make if right is less than right minus 1, then right is the pivot.
Could you repeat that?
Just to avoid, I say if the right was less than right minus 1, then right is the pivot. Just to avoid many search.
Yeah, this is in this particular case, but remember the pivot is created at random. So that might not particularly be the case in all scenarios.
Can we try something?
Many search.
Sorry, Musif, yes. This is your condition. Is there something? I think something is wrong with this condition. I don't know. Please correct me if I'm wrong.
This one is wrong. I think it's wrong. Because mid is index and this is value.
It should be exactly. You've seen it. Yeah. Right.
I mean nums mid bigger than nums mid plus 1.
Okay.
So exactly. Right.
Yes, he's right.
Okay, let's do nums. Let's do just n and we understand it nums.
Okay. Yeah, so the whole point is if you find the pivot, then what next?
Like, what if instead of searching for the pivot point, then we just continue with, essentially we have two arrays and our target can only be in one of those two arrays, right? We have the higher section and the lower section. The lower section is ahead of the higher section. So if our target is, let's say, 4, then we would, what if we just did our initial binary search as it was previously, but we also check the values of the leftmost and the rightmost indexes, right? So we would check to see if our midpoint is greater than the rightmost value, right? If that midpoint value at that midpoint is greater than the value at the rightmost position, it would mean that, and it is greater than our target, which is 4, it would mean that we don't need anything beyond the midpoint. So we can still continue with the binary search, but now we have reduced the search parameters significantly by continuing with the same idea of the binary search. So maybe we can try along those lines, see what happens. Does that make any sense?
That was what I suggested initially.
We need to solve it and solve this problem, but the way you described it is actually easier than try to define the pivot and change it, but it's will be a bit harder to explain because we have, like you said, it's two arrays. It's two, one it's less. So you wanna know which one. That's what the first thing we find the middle. If the target is bigger than the middle, and everything left is not. But the problem arises when we try if the target is less, because if it's less than the midpoint, it has two possible way to go. It could go left in the array left or in the array right, because the array right contains the portion of the left of the less value. That's where the problem arises, but it's a bit difficult to understand it.
Okay. Maybe we just solve it normal way and we'll lead this one to the other PLD because it's already too late here. Or we can stop here and try to do this one next session. I think that will be better because now it's 9 p.m. But it was so fun. Like I did really enjoy this idea, and I was really excited to see how it's gonna work. You guys are amazing. Okay, so next session is a matrix. It's gonna be tomorrow, and Saturday and Sunday we have. But matrix is very short. Like it's not that. I think it's 1 hour. I think the list code of it is not. So we can like do this one. Continue this one. Anyone have question? Want to add something? We can discuss something like quickly. And yeah, I want to thank you guys for coming. Like I learned a lot. That's amazing. I hope you guys.
Sorry, before we leave, sorry. Are we still going to come back to this, or I don't understand?
Yeah, we try tomorrow to.
Tomorrow,
okay. This.
Maybe
maybe if each one of us like try to maybe think about a bit. So like when we come, we are like have ideas, right? Because this will be cool. Like if we figure out the pivot.
Okay. Yes. No.
Okay. Anyone have something to say? Ingasi, Manitala, Pacman.
Okay.
All good? Okay.
I learned a lot today. Thank you, guys. Thank you so much.
Yeah, me too. Okay. Have a good night, beautiful and everyone. Good night.
Peace.
Peace.